Hi guys, so I'm going to do question 5 part A of the 2019 paper. So it's question 5 part A, and this is a trapezoidal rule. So a trapezoidal rule is basically when we have an irregular shape like this, generally looking like something like that, and we apply this rule which is given in our log tables, and what we need to do is we need to estimate the area here. So it's divided into generally equal segments like this, and we get heights, and from that we can work out what the estimate for the area is. Now, this one's a little bit more complicated because it's given a grid. Now I couldn't put the whole grid up here, but it tells you a little rule. It says that for every centimetre on the grid, right, it's equal to 3 metres in real life. So on the grid we had 8 different 1 centimetre sections along here. So each of them representing 3 metres means that it's 3 metres here, 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 here. So it would be 24 metres in total across there. Now we don't actually need the 24 metres, but that's how it works. So we measure across the amount of boxes. It's 8 boxes. Each box is 3 metres. So we do 8 by 3 gives us 24. Same with the height. Now the height is slightly different. It says each box was 1 centimetre by 0.5 high. So every box high is 0.5 centimetres. So in this case, right, it was 2.5 centimetres from here to here. Right, so it's 2.5 centimetres. So I times that by 3 and it's 7.5 metres this height. This one was 3 centimetres from top to top. It was 6 boxes of 0.5 high. So I did 3 by 3, which gives me 9, and so on and so on. This actually is the same as this here. So there's a couple of different ways of doing it. We could work out the top half using the trapezoidal rule, using all this information here and double it, or we could add it all together. Okay, so if we add it all together, instead of having 7.5 and 7.5, we go for the whole line through, because it's the same line, and we change that to 15. And 9 and 9, we change to 18. And then again, 7.5, 7.5, we do 15 again. 6 and 6 gives us 12. This gives us 15 again. This gives us 18. And finally, we get 15 at the end here. Now, don't forget, it starts off at 0 and starts off at 0 there. It doesn't matter if we do it this way and put it all into the formula, or we did it half of it and then doubled it at the end. So the formula is given in your exam paper. Now, the formula is a little bit, or not an exam paper, in your log table books. The formula looks a bit tricky, but how I like to do it is I just like to learn it off by heart. H is this distance here. So the formula is H over 2. And that's always whatever H is over 2. So in this case, it's going to be 3. H is equal to 3. The first plus the last height. So this is the first height 0, this is the last height 0. So I can write F is equal to 0, L is equal to 0, plus 2 times the rest. So in brackets there, I double the rest. So I add up all these here, and I double it. So what I'm going to do is just going to write it out fully for you here. So H is going to be 3 over 2. And then my first one here is going to be 0, plus 0 at the end here. Right? And then I'm going to add up twice everything. So I'm going to go 2 times 15, plus 18, plus 15 again, plus 12, plus 15, plus 18, plus 15, close it. And when I put that into my calculator, so you can put it into the calculator, you can simplify it if you want, but you put it in as a whole, I'm going to get the area is equal to 324 meters squared. And that's how we do the trapezoidal rule. Sometimes to make you measure out the things yourself, or as we used here, we did a little bit of scaling because you had to times it by 3, but generally they will give you the measurements. And sometimes, unfortunately, you might have to work backwards. So you might have a variable in here, but we'll cross that bridge when we come to it. So that's how you do the trapezoidal rule here, and it is given in the exam, but that's just a simplified version of it.